Lotus Academy of Diet and Fitness.
Comprehensive food science.
Chapter 4. Food Packaging and Shelf Life. Food packaging. Food packaging is a crucial element in preserving the quality, safety, and shelf life of food products. Its multifaceted role involves employing diverse materials and techniques to shield food from contamination, spoilage, and physical harm. Key aspects of food packaging and its impact on shelf life encompass protection from contamination. Packaging acts as a barrier, shielding food from external factors like microorganisms, pests, dust, and pollutants. This preventative measure maintains food integrity and safety by averting microbial growth, cross-contamination, and exposure to harmful substances. Preservation of freshness. Packaging materials and techniques extend the shelf life of perishable foods by minimizing moisture loss, oxidation, and microbial spoilage. Modified atmosphere packaging and vacuum packaging create controlled environments, slowing the growth of spoilage, causing microorganisms and delaying food quality degradation. Physical protection. Packaging provides a safeguard against damage during handling, transportation, and storage. It shields against impacts, compression, vibration, and temperature fluctuations that could compromise food integrity, texture, and appearance. Barrier properties. Packaging materials can possess specific barrier properties safeguarding food from moisture, light, oxygen, and odors. For instance, moisture barrier properties prevent texture and stability issues, while oxygen barrier properties maintain freshness and prevent oxidative deterioration. Information and labeling. Packaging serves as a platform for crucial consumer information, including nutritional facts, ingredients, allergen warnings, and storage instructions. Clear labeling aids consumers in making informed choices, understanding handling requirements, and checking expiration dates. Portion control and convenience. Packaging enables portion control and convenient usage, reducing waste and ensuring accurate serving sizes. Single-serve, resealable packages and portion sachets enhance convenience while maintaining freshness. Sustainability. Sustainable packaging practices aim to minimize environmental impact by reducing waste, utilizing recyclable or biodegradable materials, and optimizing design for efficiency. This approach aligns with both preserving food quality and minimizing environmental harm. 4.2. Food packaging and protection from contamination. Food packaging is essential for safeguarding food from contamination. It serves multiple protective functions. Physical protection. Packaging acts as a barrier, shielding food from physical hazards like impact and puncturing during handling, transportation, and storage, preventing quality compromise. Microbiological protection. Packaging serves as a barrier against microorganisms, safeguarding food from contamination by bacteria, viruses, and molds during handling or in the environment. Chemical protection. Packaging materials create a barrier against chemicals, preventing migration of harmful substances into food, guarding against contamination from pesticides, heavy metals, or other hazardous chemicals. Moisture and oxygen control. Packaging materials regulate moisture and oxygen levels, inhibiting spoilage, causing microorganism growth and slowing down oxidation processes, preserving food quality. Tamper resistance. Packaging offers tamper-evident features like seals, bands, or caps, ensuring consumers can identify if the food has been compromised. Allergen separation. Proper packaging and labeling practices prevent cross-contamination between allergenic and non-allergenic foods, reducing the risk of allergic reactions. UV protection. Some packaging materials, especially for beverages, provide UV protection, shielding contents from light exposure that can degrade quality or nutrients. Extended shelf life. Effective packaging systems like vacuum-sealed bags or modified atmosphere packaging extend the shelf life by maintaining optimal conditions and inhibiting microbial growth. 4.3. Food packaging and preservation of freshness. Food packaging plays a vital role in preserving the freshness of food products. Here are some ways food packaging helps maintain freshness. Barrier protection. Packaging acts as a barrier that prevents the exchange of air, moisture, and odors between the food and its external environment. It helps to maintain the desired moisture levels, prevents dehydration or moisture absorption, and minimizes the exposure to external odors that can affect the freshness of the food. Oxygen control. Oxygen is a major contributor to food deterioration as it can lead to oxidation processes that degrade the quality and freshness of food. Packaging materials with oxygen barrier properties, such as certain plastics or laminated films, help reduce oxygen permeability and preserve the freshness of perishable food items. Moisture control. Packaging materials can regulate the moisture levels surrounding the food. Moisture control is critical in maintaining the texture, crispness, and overall quality of many food products. Packaging with moisture barrier properties helps prevent moisture loss or absorption, preserving the desired moisture content of the food. Light protection. Packaging materials can provide protection against light exposure, particularly ultraviolet, UV light. Light exposure can cause quality degradation, such as color changes, vitamin degradation, and flavor alterations. Packaging with light-blocking properties helps shield the food from harmful UV rays and preserves its freshness. Temperature regulation. Packaging can contribute to maintaining the desired temperature conditions for food products. Insulated packaging or packaging designed for temperature control, such as coolers or thermal bags, helps to preserve the freshness of perishable items by maintaining their desired temperature range. Microbial barrier. Packaging acts as a physical barrier against microorganisms, preventing their entry and reducing the risk of spoilage or foodborne illnesses. Properly sealed packaging minimizes the chances of microbial contamination and helps preserve the freshness of the food. Aseptic packaging. Aseptic packaging is a method used for preserving the freshness of liquid or semi-liquid foods. It involves sterilizing the packaging materials and filling them under sterile conditions, which helps to extend the shelf life and preserve the freshness of the products without the need for refrigeration. 4.4. Food packaging and physical protection. Food packaging provides important physical protection for food products. Here are some ways in which food packaging offers physical protection. Cushioning. Packaging materials, such as foam inserts, bubble wrap, or air-filled pouches, provide cushioning to protect delicate or fragile food items from physical shocks and impacts during handling, transportation, and storage. This helps prevent damage to the food and maintains its quality. Containment. Packaging forms a secure enclosure around food products, preventing them from spilling, leaking, or being exposed to external contaminants. It keeps the food intact and maintains its original form, ensuring that it reaches consumers in optimal condition. Structural integrity. Packaging materials, such as sturdy boxes, trays, or bottles, provide structural integrity and stability to food products. They help maintain the shape, form, and arrangement of the food, reducing the risk of deformation or distortion during transportation and storage. Barrier protection. Packaging acts as a physical barrier against dust, dirt, insects, and other external contaminants that could potentially affect the quality and safety of the food. It creates a protective shield that keeps the food clean and free from unwanted particles. Waterproofing. Packaging materials with waterproof properties, such as laminated films or coated papers, protect food products from moisture and liquid penetration. This is particularly important for perishable foods or items that may be damaged by exposure to moisture. Tamper resistance. Packaging can incorporate features, such as seals, closures, or tamper-evident bands, to provide tamper resistance. These features help consumers identify if the packaging has been tampered with, ensuring the integrity and safety of the food. Stackability. Packaging design and materials are often optimized for efficient stacking and storage. This ensures that food products can be stacked safely without collapsing or being damaged, maximizing storage space and minimizing the risk of accidents. Ease of handling. Packaging is designed to facilitate easy and safe handling of food products by consumers, retailers, and distributors. Ergonomic features, such as handles, grips, or tear notches, make it convenient to carry, open, and portion the food. Food packaging and barrier protection. Food packaging plays a crucial role in providing barrier properties that protect food products. Oxygen barrier. Packaging materials can act as a barrier against oxygen, which helps prevent oxidative reactions that lead to food spoilage, flavor changes, and nutrient degradation. Oxygen barrier properties are particularly important for preserving the quality and freshness of products sensitive to oxidation, such as fats, oils, and certain beverages. Moisture barrier. Packaging materials can provide a barrier against moisture, preventing the entry of water vapor and controlling moisture levels surrounding the food. This helps maintain the desired moisture content of the food, preventing dehydration or moisture absorption that can impact texture, taste, and microbial stability. Light barrier. Packaging materials can offer protection against light, especially ultraviolet, UV light. UV light exposure can cause photochemical reactions in food, leading to nutrient degradation, off flavors, and color changes. Light-blocking properties help preserve the sensory and nutritional quality of light-sensitive food products. Aroma and flavor barrier. Packaging materials can act as a barrier against the transfer of odors, flavors, and volatile compounds between the food and its external environment. This helps maintain the integrity of the food's flavor profile and prevents unwanted cross-contamination of aromas. Microbial barrier. Packaging forms a physical barrier that protects food from microbial contamination. It prevents the entry of microorganisms, such as bacteria, yeast, and molds, from the environment, reducing the risk of spoilage and foodborne illnesses. Tamper resistance. Packaging can provide tamper-evident features, such as seals, closures, or indicators, to protect against tampering and unauthorized access to the food. These features help ensure the safety and integrity of the packaged product. Barrier to migration. Packaging materials can act as a barrier to prevent the migration of substances from the packaging material into the food. This is particularly relevant for certain plastics, coatings, or printing inks, ensuring that the food remains free from harmful or unwanted substances. Containment barrier. Packaging provides a physical containment barrier, preventing leakage, spills, or contact with external contaminants. It protects the food from physical damage during handling, transportation, and storage, ensuring its quality and safety. Food packaging and information and labeling. Food packaging serves as a platform for providing important information and labeling to consumers. Product identification. Packaging displays essential information for product identification, such as the product name, brand logo, and product description. This helps consumers quickly identify and differentiate the food product from others on the shelf. Ingredients. Packaging includes a list of ingredients used in the food product. This allows consumers to be aware of the components present, helping them make informed choices based on dietary restrictions, allergies, or personal preferences. Nutritional information. Packaging provides detailed nutritional information, including serving size, calories, macronutrient content, such as fat, carbohydrates, and protein, and micronutrient content, such as vitamins and minerals. This information helps consumers understand the nutritional composition of the food product and make informed decisions about their diet. Allergen information. Packaging includes clear allergen labeling to identify the presence of common allergenic ingredients, such as peanuts, tree nuts, wheat, soy, milk, eggs, fish, or shellfish. This helps individuals with food allergies or sensitivities to avoid potential allergens. Net weight or quantity. Packaging indicates the net weight or quantity of the food product, allowing consumers to assess the amount of food they are purchasing. Country of origin. Packaging indicates the country or countries where the food product was grown, produced, or manufactured. This information helps consumers make decisions based on preferences or concerns regarding the origin of their food. Date markings. Packaging includes date markings such as the production or manufacturing date, best before date, or expiration date. These markings provide guidance on the freshness, quality, and shelf life of the food product, assisting consumers in determining its suitability for consumption. Preparation and storage instructions. Packaging often includes instructions on how to prepare, cook, store, or handle the food product. This helps consumers properly handle and store the food to maintain its quality, safety, and optimal freshness. Environmental labels. Packaging may include environmental labels or symbols to indicate eco-friendly packaging materials, recycling instructions, or other sustainability initiatives. This helps consumers make environmentally conscious choices and encourages responsible disposal or recycling practices. Food packaging and portion control and convenience. Food packaging plays a significant role in portion control and convenience for consumers. Single-serving packaging. Many food products are packaged in single-serving portions, offering pre-measured quantities that help consumers manage their portion sizes. This promotes portion control by providing a convenient and controlled amount of food for individual consumption. Portion indicators. Packaging may include portion indicators or markings, such as portion sizes or recommended serving sizes, to guide consumers in determining appropriate portions. This visual reference helps consumers make informed decisions about the amount of food they consume. Pre-packaged meals and snacks. Pre-packaged meals and snacks provide convenience by offering ready-to-eat or easy-to-prepare options in pre-portioned packaging. This saves time and effort in meal planning and preparation, allowing consumers to conveniently access portion meals or snacks when needed. Individual packaging. Packaging individualizes food items, making it convenient for on-the-go consumption or for portioning out servings. This is particularly useful for items like snack bars, cookies, or chips, allowing consumers to control their intake and carry them easily. Resealable packaging. Packaging with resealable features, such as Ziplocs or resealable pouches, helps maintain the freshness and integrity of the food product. This convenience allows consumers to open, consume a portion, and reseal the package for future consumption, preserving the quality and extending shelf life. Microwavable and oven-safe packaging. Packaging designed to withstand heating, such as microwavable trays or oven-safe containers, provides convenience in reheating or cooking prepackaged meals. This allows for quick and hassle-free meal preparation, saving time and effort. Portion-controlled packaging. Some packaging designs incorporate portion control mechanisms, such as compartments or dividers, that separate different components of a meal or control the amount of each component. This helps consumers manage their portion sizes and maintain a balanced diet. Grab-and-go packaging. Packaging that enables easy grab-and-go access, such as individually wrapped sandwiches, salads, or snack packs, provides convenience for busy consumers. It allows for quick and portable consumption without the need for additional preparation or utensils. Food packaging and sustainability. Food packaging and sustainability are interconnected, as the choice of packaging materials and practices can significantly impact the environment. Here are the ways in which food packaging can contribute to sustainability. Sustainable materials. Choosing packaging materials that are renewable, recyclable, or compostable can help reduce environmental impact. Materials such as paper, cardboard, glass, metal, and certain types of plastics can be more sustainable options when sourced responsibly and properly managed at the end of their life cycle. Recyclability. Packaging that is designed for easy recycling, with clear labeling and instructions, promotes the recovery of materials for reuse. Encouraging consumers to recycle packaging materials reduces waste and conserves resources, minimizing the environmental footprint. Optimizing packaging designed to minimize material usage without compromising product safety and integrity reduces waste and resource consumption. Using lightweight materials or right-sizing packaging helps conserve materials and reduce energy needed for production and transportation. Biodegradability and compostability. Packaging materials that are biodegradable or compostable under appropriate conditions can contribute to sustainability. These materials break down naturally in the environment, reducing waste and potentially providing valuable organic matter for composting. Renewable energy sources. Utilizing renewable energy sources in the manufacturing and production of packaging materials can reduce greenhouse gas emissions and reliance on fossil fuels. Renewable energy, such as solar or wind power, can power manufacturing facilities, reducing the carbon footprint. Life cycle assessment. Conducting life cycle assessments of packaging materials and practices helps evaluate the environmental impacts throughout the entire life cycle, from raw material extraction to end-of-life disposal or recycling. This analysis enables informed decision-making and the identification of opportunities for improvement. Packaging waste reduction. Implementing strategies to reduce packaging waste, such as lightweighting, using reusable packaging options, or promoting bulk purchase options, helps minimize the amount of packaging that enters the waste stream. Innovations and alternative solutions. Embracing innovative packaging technologies and exploring alternative solutions, such as bio-based materials, edible packaging, or packaging-free options, can contribute to more sustainable practices in the food industry. Shelf life determination and prediction in food packaging. Shelf life determination and prediction are essential aspects of food packaging to ensure the quality and safety of food products throughout their intended storage period. The shelf life of a food product is the period during which it remains safe to consume and maintains its desired quality attributes, such as taste, texture, color, and nutritional value. Here are the key steps and factors involved in shelf life determination and prediction in food packaging. Product characterization. Understanding the composition and properties of the food product is crucial. This includes analyzing its chemical, physical, and microbiological characteristics, as well as identifying any sensitive components that may degrade over time. Packaging material selection. The choice of packaging material can significantly influence the shelf life of a food product. Factors like barrier properties, permeability to moisture, oxygen, and light, as well as interactions between the food and packaging material must be considered. Accelerated Shelf Life Testing (ASLT). This method involves subjecting the food product to stress conditions, elevated temperature, humidity, to accelerate the deterioration processes that occur over time. By monitoring changes in quality attributes under these accelerated conditions, scientists can estimate the product's shelf life more rapidly. Real-time shelf life testing. In this approach, food products are stored under normal storage conditions, and their quality attributes are periodically monitored over time until they reach an unacceptable level. This method provides a more accurate representation of the actual shelf life but requires more time to obtain results. Sensory evaluation. Sensory analysis involves the evaluation of the food product's appearance, taste, odor, texture, and overall acceptability by trained panelists. Sensory data can be used to determine when a product's quality reaches an unacceptable level during shelf life testing. Microbiological analysis. For perishable foods, monitoring the microbial load is crucial as the growth of spoilage microorganisms or pathogens can impact the safety and quality of the product. Modeling and predictive software. Mathematical models and predictive software can help estimate the shelf life based on data collected during accelerated and real-time shelf life testing. These models consider the rate of deterioration and help forecast the time it takes for the product to reach its end of shelf life. Regulatory considerations. Food packaging and shelf life claims are subject to regulations in many countries. It's essential to comply with the appropriate regulatory guidelines and provide accurate and verifiable shelf life information. Packaging design and quality control. Ensuring the integrity of the packaging is critical to prevent any external factors from impacting the food product. Proper quality control measures are necessary to verify that the packaging is functioning as intended. Thanks for tuning in. Don't miss out on captivating content about diet and fitness. Subscribe now